Hello everyone, my name is Ramin Senov and today's topic is parallel, perpendicular, and same lines. So let's start our class. First, we will discuss what parallel lines are. Let me just write in here, parallel lines. Now, from our last lesson, you should already remember that a line has an equation formula which was y equals to mx plus b. This was a standard equation formula. And in this case, parallel lines are just a set of two lines. So let me draw two lines. Let's say I want the first line to be something like this. And let me draw a second line. And let's say I want it to be something like this. Great. Now, in this case, let's say that this red line has an equation formula y equals to m1x plus b1. Now, you might wonder why I wrote m1 b1. It's just to differentiate with the blue line. I will explain it right now. Let's say that this is our first line, and let me write the formula of the second line, of this blue line right here. Now, in this case, let's call it the second line. So it will be y equals to m2 x plus b2. I wrote m1, m2, b1, b2 just to differentiate between them. Now, what are parallel lines? They are lines that never intersect each other. So, for us, intersection was when two lines crossed each other. Basically, this would be considered our intersection point. But because our lines are parallel, they will never ever touch each other. They will always be separate from each other in a way. Now, we have two simple rules. They're really simple. M1, we will be starting to compare those equation formulas. Now, M1 must always equal to M2. This is the first and the most important rule so that you can actually see which lines are parallel. And then the second rule is B1, it can never ever equal to B2. This is this simple. We have just two simple rules. Now, let's say we have a question and we are told that the first line, it has, like, it's given like this. Y equals 5x plus 2. And we have a second line, which is y equals to mx minus 7. We are told that these two lines are parallel. Yeah, and we need to find what m equals to. Simple. First, we have to check whether b1 equals to b2. In this case, b1, let me pick another color. b1 is 2 and b2 is negative 7. So they're not equal to each other. That's a good sign. And now let's just put a check in here, a check mark. And now let's compare the basically slopes. M1 is 5, and I don't know what my M2 equals to, right? If I'm told that they're parallel, M1 must equal to M2. This is our rule. So in this case, this M right here will just equal to 5. That's it. And let me show you how you can see it in Desmos. Now, these are two lines. I just wrote random two equations, but they have the same slopes and they have different y-intercepts. This is all we need. And no matter how much I zoom out, if I zoom in, I will see that my lines, they never intersect each other. As you can see, they're separated from each other. This is what parallel lines are. Now, let me teach you perpendicular lines and the same lines, and we will start solving some questions. So, now let's get to perpendicular lines. Great. So, Again, we have two sets of lines, two pairs of lines. Let's say our first line is something like this. It just goes like this. Then our second line, let's just say it will be something like this. Again, I'm drawing these lines just to demonstrate everything. What are parallel or perpendicular lines considered? Now, when intersecting perpendicular lines, they create a 90-degree angle. So this is 90, this is 90, this is 90, and so on. This is what separates perpendicular lines from just any other normal two pairs of lines. In this case, because we have an intersection point, perpendicular lines will always have only one solution. And I did not say it for parallel lines because parallel lines, they never intersect each other. In this case, they will have zero solutions. If you remember, for us, a solution is considered when two lines, they intersect each other. And because parallel lines, they never intersect, we will simply have zero solutions. Let's get back to the perpendicular lines. Now, in the future, you might see another name for perpendicular lines, which is tangent. I'm just saying it now so that in the future, when you see this word, it basically means that when intersecting, your lines create a 90-degree angle, or basically perpendicular lines. Great. How do we find or create perpendicular lines? Now, let me again write equation formulas. Let's say that this red line, it has y equals m1 x plus b1. Great. This is our first equation. And let's say that our green line, it has y equals to m2 x plus b2. In this case, we have one rule only. m1, our slope 1, multiplied by m2, which is our second slope, it must equal to -1, always. There is no other way, like it always has to equal to -1. For example, let me give you an example. Let's say we have two lines. The first one is 5x plus, let's take 7. And then we are told that we also have a second line, y equals to, let's call it cx minus 8. Great. And these two lines, we are told that they're perpendicular. And we need to find the letter c. As we can see, this c right here is our slope because it is next to our letter x. In this case, the letter that is next to our x it will be considered our slope. Great. Now, because I remember that m1 multiplied by m2 should give us -1, I can say that 5, which is our m1, multiplied by c, which is our m2, it should give us -1. So, c, because we need to find the value of c, right? I will just isolate it here. Now, because in here we're actually multiplying, when I change or put the 5 to the right side, I will be dividing. So it will be -1 over 5. So our second slope, or basically c, will simply equal to -1 over 5. This is it for perpendicular lines. I hope you understood everything. And finally, let's get to our same lines. This is one of the easiest things. Let's say we have one line, and let's say we have another line, which will lie on top of it. They're basically the same lines, as the name suggests. So, in this case, the green line, it has y equals to m1 x plus b1. Great. And the red line, it will have y equals to m2 x plus b2. Now, as the name suggests, they're basically the same. m1 equals to m2, b1 equals to b2. They're lying on each other. They're basically on top of each other. They're not separated at all. Let me show you an example. Let's say our first line is 5x plus 1. The second line will be exactly the same thing. It will be 5x plus 1. Now, because, again, for us, when we have two or more lines, a solution is considered their intersection point. And in this case, because they're the same exact lines, they lie on each other, so they will keep intersecting infinitely many times. They will never separate from each other. And in this case, the same lines have infinite amount of solutions. Great. I hope you understood everything up until now. So let's get to solving some questions. Let me zoom out. Great. Let's start from our first question. Which line is parallel to this line right here? Now, if we remember parallel lines, m1 equaled to m2 and b1, it did not equal to b2. Great. So, let's take a look at our answer choices. In this case, our m1, let's call it m1, it equals to 2. So, our m2, it also has to equal to 2, right? Answer choice A. As I can see, my slope equals to negative 1 over 2. This is not acceptable. We are looking for 2. So, this goes away. And let's look at answer choice B. In this case, we will have 2x minus 7. Perfect. Let me change the color. So this 2 is our m2, which is our second slope, and negative 7 will be our b2. As we can see, m1 equals to m2, like these two, and b1 does not equal to b2. Great, you found your answer. Let's solve question number 2. A line has a slope m equals to negative 2. What is the slope of any perpendicular line to it? As we covered, perpendicular, basically m1 multiplied by m2, they should give us negative 1. So, if this is our m1, negative 2 multiplied by, let's call it m2, should give us negative 1. So, m2 will equal to, again, because I'm multiplying, when I will change to the right part, I will divide. It will be negative 1 divided by negative 2. We have two negative signs, they will just go away. We will be left with 1 over 2. That's it. Let's solve question number 3. So, we have two lines. We are told that line A and line B are perpendicular. What is the value of m? Again, slope 1 multiplied by slope 2 equals to negative 1. This is our slope 1, and this is our slope 2. So negative 1 over 2 multiplied by m should give us negative 1. So m will just equal to negative 1 divided by negative 1 over 2. And when we're dividing something, when we're dividing a fraction, we have to flip it. It will become, let me write in here, negative 1 multiplied, because we are flipping, it will become multiplication instead of the division. So it will be multiplied by negative 2, or simply it will just equal to 2. That's it. Let's solve the fourth question. Determine whether the two lines are perpendicular or neither. Now, we should isolate y always. It must be by itself. What I mean by this is, in this case, everything is perfect, but when I look at our second line, it has this 2 right here, which is not acceptable. So, because this is a multiplication, we will just have to divide our equation by 2. It will be y equals to 10 divided by 2x minus 8 divided by 2. Or it will equal to 5x minus 4. This is our first line. And our second line is, let me show you. Our second line is y equals to 5x plus 1. I got it from here. So our slopes are equal and y-intercepts are different. So in this case, these lines are parallel. And let's solve our last question of the day, which is the sixth question. A line passes through the point 1 and 2 and is perpendicular to this line right here. Write the equation of the line in slope-intercept form. Now, we have a coordinate, which is great. Yeah. The next thing we need to do is, because we are told that, let's call this part line L. Or, yeah, line L. So, and we have another line, which is our second line. Let's call it line N. We are told that line L and line N are perpendicular. So, what I can do is, I can find line L's slope. It is 3 over 4, right? So, because it's 3 over 4, let's call it M2. So this is M2. And let me write line L. It is just mx plus b, because for now, I don't know any value. I don't know what m equals to, and I don't know what b equals to. But I know one thing. M right here multiplied by m2 must give me -1 because these lines are perpendicular, right? So let me plug in 3 over 4 instead of m2. M multiplied by 3 over 4 will equal to -1. So m will equal to -1 divided by 3 over 4. And when dividing, we used to basically flip the fraction, and instead of dividing, we would multiply. So it will equal to -1 multiplied by 4 over 3. And if I multiply, we will just get -4 over 3. Great. Now I can actually update this equation. So our equation right now is y equals to -4 over 3 x plus b. And we have this coordinate. Please don't forget about it. So 1 is our x value and 2 is our y value, right? Technically, when I plug in 1 for x, my output should be 2. I can solve it by hand. Let me first solve it by hand. It will be 2 equals to -4 over 3 multiplied by 1 plus b. So, -4 over 3 multiplied by 1 is the same thing, right? So we will have 2 equals to -4 over 3 plus b. And because we need to find the value of b, b will equal to, in this case, because this has a negative sign, when throwing it to the left part, it will change to a plus sign. It will be 2 plus 4 over 3. Now, we need to find the same bottom parts. Because it's 3 in here, in this case, it also must be 3. And if I'm adding 3 on the bottom part, I have to multiply the upper part by 3. It will be 2 multiplied by 3, 6 over 3, plus 4 over 3, or simply 10 over 3. Now, we got our full equation form, which is y equals to -4 over 3, x plus 10 over 3. Great. Basically, this is the answer to this question. This is one way, but we can also solve it using Desmos. Let's remember up until here, because up until here, you have to do it by hand. Let me open up Desmos. Great. Now, I can plug in, or I can write a function. I simply can change this letter y to f of x. Now, it means the same thing. It will be just a little bit comfortable for me. Let me show you why. So let me again open Desmos. When I write with f of x, and let me just write my function. So negative 4 over 3 x plus b. Instead of b, I will just write 7 to demonstrate you. When I write f of x, if I write f, open parentheses, and then plug in, let's say 2. This actually, 2 is like for x, right? It goes into your equation, plugs in 2 instead of x, and gives us the value of the function, which is really comfortable. But because it's b right here, I will just leave it as it is right now. Second step, please pay attention to this part. When we have letters that we don't know the values of, or we don't know the values for, we always use the regression sign, which is this sign right here. What I need to do is f, open parentheses, I will just plug in my coordinates. 1 is x, 2 is y, right? I can say that f of 1, this sign, equals to 2. And it will just find the value of b for me, or you can write b yourself and click this button. It will just turn it into a fraction. It's the same thing that we found. But yes, I hope you enjoyed this video. Thank you so much for watching, and see